In this video, I'm going to show you how I used SolidWorks, a 3D printer, and some home handyman skills to upgrade my home networking mess. Show you how I design in SolidWorks, sketch, 3D print, go through prototyping phase, and then in the end, install and clean up the entire area just to make it look a little bit neater. I've timestamped the video, so if there's any section you're not interested in, feel free to just jump through the chapters and see the final result at the end. Let me know what you think.
We recently upgraded the modem. It's currently sitting here until I mount it. We have the Ethernet splitter, the power supply. We have the incoming NBN, and then we have a wireless access point here as well. A couple of power points. This, which is no longer required. So plenty of stuff that's just looking like a milk-toast breakfast. And the intention of this project is to clean this up, hide the cables. Imagine this one as well. There's even more cables with this one in place. So that's another thing that we'll need to do. We do have to retain access. So it has to be something that we can take on and off, like we can with this cover. All right, we should make the wireless access point and everything look more cohesive. And I still want to maintain access to these power points here. I'd be quite happy to have everything contained above this line where the power points are. So that section contains all the modules, the units, but I can still come here and plug in a new device, plug in something if I need the high pressure hose or something. I've still got the power points here to plug in. It could be even that I just move those two up so it's only the bottom one that's visible, because I do only have one spare slot. This is currently held on with adhesive. This has a couple of screws. Need to work out how to mount all these things too. But with the 3D printing, I can just design some features in there or a clip or something to make it really easy. So my initial intent is just to get some rough dimensions. Now all this stuff can move, so there's no problem with that. These can move, this can move. This one, I think there is a hole there, so that can't move. But even then, the cable can be repositioned. So there are some things that can move around, so the exact dimensions don't matter too much. The dimensions of these do, the positions of these do, so those will be things that I'll try and capture accurately. So let's just get into it. If we just start by drawing kind of the frame, the position that we're in, what we can do is draw everything first so that we get our bearings and then put in the dimensions afterwards. So I might just grab this precision tool so I can do some rectangles and duplicate that, partial on, because I've got 1, 2, 3, 4, 5 of those, but we'll get rid of the top one. So I'm only going to do the 4, but we may as well just draw all the boxes and we'll add the dimensions to them afterwards. So 1, 2, 3, 4, ditching this one, grab all those and try and get approximate positions. We'll put the dimensions in afterwards. So I've got that one there. As I said, these two don't really matter. I'll actually get separate dimensions for these later when I pull it all apart to model it accurately in space. So I've got the rough layout. Now some accurate dimensions or positions. So like I want to get this length here so I can work out, okay, where exactly do I want to put that point? Like how long do I want to make this whole module? So I'm going to get my dimension there to this bottom one, work it out.
So as I'm getting started, I'm just setting up my screen as I would normally with my ultra-wide or dual monitors, with any reference images in place. Normally I'd have them off to the side, but here I'm just showing them on the one screen so you guys can see what I'm working from. So that's my completed sketch up in the top left with the rough dimensions. You can see they are very rough. There's no need to be pretty here. The sketch is purely for reference. So long as I've got the information I need, that's all it needs to be. And then I'm using the photo in the bottom left just to make sure I'm kind of aligning where the cables are, where the existing boxes are, with what I'm putting in the model. So that, I don't mistakenly interpret one box for another. It is a long way from the garage upstairs here, so it is plenty of time to forget things. So as I'm doing the model here, I've done a basic wall section and I've done the bottom of the overhead shelf as my reference point, and I'm using those dimensions that you can see just to set things up. And then for, the main components, I'm just roughly putting them in place. Now, the dual outlets, the power points that you can see there, they're an existing part that I have in a library that I call on from time to time. They might not be the exact dimensions of the ones I have in the wall, but they're going to be very close and they're representative, and that's all I need for now. Whereas you can see the box that I'm creating here, this is with accurate dimensions where I've marked out, the keyholes, the width, height, width, and depth. And I'm even here applying a decal so that I can see the ports that are part of that Ethernet router. Now, you didn't see it here on screen, but off screen, I would have gone to the website for that product, found a front-on view, taken a screenshot, cropped it, and then brought it into SolidWorks as a decal. It's a very quick way for me to approximate the position of those ports or lights, LEDs, without having to actually go to physically measure them. So I've customized a couple of those outlets there for the Ethernet ports, the 4-point and 6-point ones. I'm getting the second component here. Again, similar process. You can see I'm just mapping those ports, the image to one side, making sure I save regularly, of course. And now just putting in some splines just to get a rough idea of the cabling. This is not, again, super accurate, but just giving me a bit of an impression of what the whole thing looks like. So I'm completing some checks, and I think my thought process here is that I might actually rotate some of these models. So you can see the one on the left here, the main new Ethernet router. I've rotated that model, so I've changed the proportions to make it vertical rather than to make it portrait rather than a landscape orientation. And I've also changed the mapping. I've just copied that mapping image from the bottom face to the side face. And now you can see where the thinking in my design is starting to change. Rather than I think trying to create something that's going to cover up absolutely everything, all the cables, all the power points, plus these two units and the power supply. Instead, I'm starting to think maybe I could put them side by side, kind of lay them, sandwich them together, and then create either a bracket or a mount that can screw to the wall and hold them in place. Be a much simpler design to get started with. And with what I'm doing here, as I'm starting out, I'm not trying to make something that's absolutely amazing. I just want something that works and is quite neat. And so start with a simple box. Start with a simple box here. I've added a couple of fillets, a couple of holes. I've got, I think these holes here lines up with, there's an LED on the front status line. So it's just giving it some access. And then the simple print also lets me check how good my dimensions are. So if I was to create like a really tall box that was covering the whole thing, complete, go ahead, do a 3D print. 3D print might take for that 3-4 hours. Come back, test it, and see that the fitting's too tight, doesn't actually get on. I've just wasted all that time. So for projects like this where, there's no time constraint on this project, I can spend as much or as little on it as I want. I will take my time and go through and do a couple of prototypes. So got it to that point, nice and simple. Let's export for 3D print and see how things turn out. All right, here's the first print. Nothing special. Change of idea with the design, such that we're just going to put a simple bracket on the wall as a starting point. There's a couple of screw holes here that we can mount through and build out from there. So here we can check the fitting, and the edge router, the main one that I need to mount, is here. So we've made that base from that hole there that we keep in clearance. That is a very nice fit. You can see we're not interfering the power cord of the bat. My theory is if I can get this screwed to the walls, that's going to do half the work for keeping this in position. So this is going to replace a couple of these units over on the right. So I'm very happy that that fits. I'm not going to screw it on yet. I'm just going to leave this here. I'm now going to go work on the design that's going to mount those two parts. Okay, so the first prototype test, it works. The fitting was quite good. I didn't take into account the small feet that were on the back of that module, but they actually helped create a nice snug fit around the bottom. So I was fairly confident that I didn't need to change anything with the overall dimensions of that. Now it's all about trying to improve the design. So my first box just fit the main larger component. What I'm trying to do now is create a second box, a second holder, a second bracket that's going to connect the second one to the first and sit them together. And so it's another test here to see if my modeling was up to scratch, that if my dimensions were correct that I've taken, to see if they're going to fit. And now I'm also starting to consider, all right, what am I going to connect between these parts? So obviously I'm connecting these Cat6 cables. So I need to make sure I've got access to those. But that access, just can be a square with a couple of rounded edges to make it look nice. Also have to make sure I'm giving access to the power outlet on the rear. So both front and rear has access where it's needed. And now we're into this point with the third component, which is the power pack, which comes with this. My one concern with the power pack was if I fully enclose it, is it going to get too hot? But this power pack had already been stuck on the wall with some adhesive for 4 years. That suggests to me that the heat coming off this power pack is not enough to really soften that adhesive and have the thing fall off the wall. So I wasn't too concerned that that was going to be a problem. Main thing with the power pack is the cables coming out from that, both ends. I just need to make allowance for those. And so as I'm trying to fit everything in a compact area on the left side of that wall towards the corner, I do need to make sure that it's not just the box components that are fitting in, also the cables that are coming in and out of those, they have room not just to connect, but also to bend. You don't want to have a really sharp connection and force a cable around a really stiff or really sharp angle. You're at risk of damaging the cable. So some of the other features you can see here, I'm thinking about how I'm fixing it to the wall. So I'm trying to do some concealed screws. The easiest way to do that is having larger access holes from the front, right? So I can put the screwdriver through and actually access the screw. It's not the end result, but something that's relatively quick and easy to put together. So a smaller hole at the rear, which the screws would mount to. Okay, so they'd hit that face and then go through to the wall anchors. Larger hole on the front so I can access or put the screw into there. Now, this wasn't the best design. It was actually quite difficult to line up the screw and get it go all the way through the hole, which you'll see when we get to the next stage of the prototypes. And at these end stages, what I was doing was just merging those files together. Merging those bodies together to make it all one large unit. I didn't want to have separate parts here. If I'm confident with the fitting, then it should be easy enough to design and print to merge it as one solid body. So a couple of quick tips on cleaning up the 3D prints. I always try with my supports material to use support PLA as the interface material. That's the kind of white line that you can see between the PLA layers, the black. That makes it very easy to snap off the supports as I'm going. There's always a little bit left on, so I use a couple of tools, sometimes a blade, sometimes a couple of other tools. I've just picked up some cheap versions from Amazon. I'm just really cleaning it up here, making sure they've got no support left on these. As a prototype, I didn't really need to do this, but I'm thinking, this looks not too bad, so let's make sure that it's got a nice appearance when I put it on the wall and nothing's sitting there that it shouldn't be. The screws fit. The screwdriver has access, so let's go put it on the wall. So you see me removing here the first, or actually probably the second little prototype, where I made just a second little bracket to see if that fits. I knew that one did. That's why I could make this a larger prototype. And here I'm checking the fitting again. I want to make sure that the cables line up. So that cable, the power access on the rear Also access for visual access for the LEDs on the front, make sure that's clear. And then similarly, the power supplies. So the large power bank, you can see the power connection on the rear of that. Now I'm happy with the fitting of those. So let's go ahead now, and I'm going to jump into some time lapse. I'm going to show you what I did to clean up this wall and get everything fitting. So you can see here what I meant by the screws. Actually getting them in the right place was kind of difficult. I didn't really have the access that I wanted. So back in my mind, I know that's something that I'm going to change when I do the next, maybe last version of this. Right, so here it's all on, it's all connected, and I think it's coming along quite well. The parts are sitting neatly. I'm able to put all the cables in. Getting the large router section in place was a bit difficult. You could see the NBN box interfered it slightly, but all in all, like, it's pretty good. But we're not quite finished. I could see that there was still some elements that I wanted to tidy up. I was probably never going to be able to hide all the cables, but I thought at least I can hide that power bank. I'm already enclosing the bottom section of those. Let's do something now that encloses the whole thing and makes it look a lot more cohesive on the wall. All right, so we're back into SolidWorks for the last time for this project. So straight away, I'm removing those holes. What I'm going to do is instead make a keyhole slot. So the design idea here is to put the screws in place on the wall, have a larger hole that fits through the rear of the mounting bracket. So the whole bracket can actually, I put the screws in the wall first and put the bracket on and then slide it down and it'll hold in place. As long as the screws are tight enough, that's going to be pretty stable. So I'm making some adjustments here to, some of the elements that I made notes of, just general notes, just mental notes, really. But there were elements of the design where I was like, oh, that could be cleaner, that could be smoother, or I didn't quite have the clearance right. So around some of the cables, around some of the LEDs. So I'm just opening up some of that space. And then here, what you can see I'm doing is modifying the design to enclose the power supply and its cables. So while not all the cables are going to be confined, while not all the cables are going to be concealed, at least that power supply will be. That will go a long way to neatening up the whole thing. So here's the keyhole detail I was mentioning earlier. Just done that with a couple of slot details. Again, I've measured the screws that I've got, so I know the head size, I know the thread size. So I just get enough suitable clearance there and I make sure they're in the right spot, and then I'm good to go. So the last elements of the design here that I'm doing are really optional, but they're around just trying to, just make the design look a bit nicer on the bottom section. I'm 3D printing, so I can do some things that you wouldn't normally do in a product. Like if I was mass producing these, I'd probably design it a lot differently than what I'm doing here and just making one. I am considering how it's going to be printed, like what orientation it's going to sit on the printer bed, what sort of clearances I'm going to need, where the support material is going to be, and where I can avoid having those supports. And now I'm at the point where I'm designing the top section. So I've decided I'm going to print two parts. The bottom one, as you can see already, with the curved shape, very similar to the black prototype that's already on the wall. But now a top section that's actually going to enclose the whole thing. That top section doesn't need to be, again, very complicated. I'll put a simple radius on top, some chamfers to match the other existing chamfers. I want to make sure that I've got the adequate clearance around the Ethernet cables that are getting plugged in. But once they're there, and I'm content with those checks for both components, you can see there's, again, I'm referring to the images I've taken and that I've placed on those models to make sure that I've got the adequate clearance for everything. The last step's just making sure that I can 3D print it and get everything to assemble. So the last thing you want to do is you look at the design as the finished state in SolidWorks and you're like, oh, it just needs a hole here, and this can have a solid wall. But then, when you're assembling it together and you have to slide it up and down over different parts, that's where you might get caught out. So I didn't do it here, but I would highly recommend you do an exploded view of your object, whatever it is you're designing. You can see, do an exploded view of your model. Okay, you can do it in parts or assemblies. Makes it quite easy then to move the component along whatever direction it's going to be assembled from. And you can just visualize then if you've got cables or other elements that come out from a body, you can see if it's going to interfere as you're pulling up and down. So with all those checks done, we're ready to hit the printer. 2 large prints. So I decided the matte white PLA would be the way to go. You'll see the way that I've orientated them in the prints. They're large enough that I could probably fit 2 on this bed at the one time, but I just wanted to be safe and only print 1. I am doing some support material from the underneath, but you can see the angles that I've got on those elements coming from the inside to the out. Those overhangs are small enough that can print without supports. That meant I was able to get a very nice finish from the bottom to the top. Any rough edges which are on the bottom face, they're hidden. So there's a little bit of cleaning, a couple of edges to pull off. I'm using my deburring tool and a couple of pliers just to pull off some of the supports. Sometimes when you're pulling these off, they can be quite sharp. So I try and use a tool where I can if I'm concerned with any sharpness. And then I'm just going over some of the edges with the deburring tool just to get anything off that's a bit sharp or a little bit rough. Just in a few places. And then we're ready for the final install. Through this next section of Timelapse, you'll see me realise now that the matte white looks really nice, but it does highlight all the other marks on the component covers, marks on the wall, dirtiness, general dirtiness, and so I want to clean things up. So I go through a process here of pulling off the components I don't need, giving everything a really good wipe and clean, filling the holes, undercoating, and a bit of painting. So it took a little longer than I would have liked. I just kind of worked on it, you know, on the odd weekend here or there. It's finished, but I would really like to get some shorter cables, maybe some white cables, clean up that element. But all in all, like, it's a big improvement for all it was. I know it's not like a life-changing design or anything like that, but it does just look a little bit neater. And when I come into the garage or walk and take the bins out, it's not something that's really ugly staring me in the face. So from that point of view, it's a win. Thanks for watching the video. Hope you enjoyed it. If you'd like to see more of this type of content, let me know in the comments. This is the kind of stuff I love doing because I'm not restricted in any way from publishing any of it. And I figure that there's different elements out there of being a SolidWorks user or designer or home handyman, DIYer that everyone could take and use in their own lives. So I'll see you in the next one.